Hello, welcome to Rising Technologies. This is Harish. You are watching part 22 of Core Java video tutorial. In this session, we are going to have an introduction to inheritance, various types of inheritance that are supported in Java, constructors in inheritance hierarchy, and super keyword of Java. Inheritance allows us to extend the capabilities of a class by creating a new class reusing the properties of existing one. Now suppose I have this class box class and that contains few properties of box, and that may be height, width and depth. Now I want to add one more property, that is weight of the box. But I don't want to modify this class. I want to create a new class, and within that class I will add that weight property. But if I create that new class from scratch, I need to again define all these properties and related behavior. So what I can do, I can create a weighted box class that inherits from this box class. So all properties and behavior that I have defined within this box class will be inherited by this weighted box class. I don't really need to define them again and again. Now all I need to do is add this additional property within this weighted box class. So what I am doing, I am reusing the existing structure of this box class. Now this class need to add only additional properties that are related to this particular type. So in this case, this box class is called as super class. It may be called as parent or base class. This weighted box class is called as subclass. It is also called as child class or derived class. So you can use any naming conventions to identify these classes. Let's take one more example. Suppose in my organization there are two types of employees, permanent employees and contract employees. Permanent employee will take annual salary, whereas contract employee will take per hour salary. But there are few properties that are common to these two types. That may be employee ID, name, designation. Now if I create these two classes separately, so you can see a lot of code within these two classes is duplicated, it is repeated. Now suppose I want to add one more property, that is gender of the employee. Then I need to add that property within this permanent employee class as well as this contract employee class. If I want to perform any kind of modification or maintenance, again I need to perform that maintenance in these two classes, and that may be definitely an error prone practice. So instead of this, what I can do, using inheritance, I can create a general class that defines common properties, and then this general class can be inherited by other more specific classes, and each class is going to add those properties that are unique to it. That means if I create this employee class, I can move all common properties, that is employee ID, name, designation and this print method within this employee class. And now I can create two more classes. These classes is going to inherit from this employee class. So I can say this is more specific class. So this inherited class or child class is going to acquire all properties from employee class. Additionally, it will add one more property, that is annual salary. Similarly, this contract employee class is going to inherit all properties from its parent class, and it will add one more feature or one more property, that is hourly pay. So this is how we can move all common code in a common class and specific code in the specific class. This is the syntax to create an inherited class. In Java, you can make use of this extends keyword to create a subclass. So suppose I have this class with the name superclass and few members of this class. In order to inherit this class into another, all I need to do is say class name of subclass extends name of superclass. So this is the syntax to create inherited class. So as per this syntax, suppose I have created this employee class and I want to create a permanent employee class that inherits from this employee. So I need to say class permanent employee that extends employee. Similarly, class contract employee that extends this employee class. Let's have a practical look at this example. To speed things up, I have already typed this three classes. I have this employee class that contains ID, name and designation and this print method. Similarly, I have this permanent employee class and contact employee class. This permanent employee class has a specific property related to permanent employee, and this contact employee class has one more property related to contact employee. Now I want to inherit this permanent employee class from this employee class, so I can say extends employee. Similarly, this class contract employee extends employee. Now, if I create an instance of this permanent employee class, that instance is going to have all combined features of these two classes. That means an instance of permanent employee class is going to have ID, name, designation, print method, plus this annual salary. Similarly, if I create an instance of this contract employee class, that instance is also going to have ID, name, designation, and this hourly pay salary. Now let's create an instance of this permanent employee class. Let's name it PE equals new permanent employee. And now I want to assign all the properties of this permanent employee. So let's say permanent employee dot employee ID equals 100 maybe, permanent employee dot name maybe Harish, permanent employee dot designation, let's say manager. And now we know that this permanent employee instance is an object of this type. So this object along with all these properties is going to have one more property, that is annual salary. So permanent employee dot annual salary, maybe this one. Okay. Now I want to create an instance of this contract employee class. Let's name it CE equals new contract employee, and let's assign all its properties. So contract employee dot employee ID 101 maybe, contract employee dot name maybe Aditya, contract employee dot designation maybe accountant, and contract employee is going to have one more property, that is hourly pay. So hourly pay maybe 450 rupees. Now I want to print the details of permanent employee as well as contact employee. So let's write a sysout statement. This permanent employee instance is an instance of this class. This class inherits from employee class, and this employee class is this print method. So this print method is also a member of permanent employee class, so I can invoke that print method on permanent employee instance. Now I want to print the annual salary of this permanent employee, so let's print that. And permanent employee dot annual salary. Similarly, I want to print the details of this contract employee. So let's copy and paste these three lines, and let's say contract employee details. So the instance of this contract employee class is also going to have this print method, and this print method is going to print all these things. So I am invoking that print method on this contract employee class, and we know that contract employee class is going to have a property, that is hourly pay. And let's change this. So just save this program, compile and run. Now look at this. It has displayed permanent employee ID, name, designation, annual salary. Similarly, contact employee details, ID, name, designation, and his hourly pay. So you can see we have actually reused these properties and this method within these two classes. Now if I want to make any kind of maintenance to this class hierarchy, suppose I want to add one more field, that is gender, and all I can do is add that property over here. So via inheritance, that field or that property will be a property of the permanent employee as well as the contract employee. Now, why inheritance? We have just seen that inheritance allows us to reuse the code, and code reuse reduces development time as well as errors. Actually, there are four important pillars of object-oriented programming, that is encapsulation, abstraction, polymorphism, and inheritance. We know that encapsulation is a protective container that encapsulates code and data together. We have already seen what abstraction is. Abstraction is hiding implementation details behind the interface. Polymorphism is the ability to take more than one form. We have already seen all these things in our previous video sessions. In this session, we have learned what inheritance is. So, inheritance is also one of the primary pillars of object-oriented programming. Now, Java supports three different types of inheritance. One is called as single, multi-level, and hierarchical inheritance. So this is the example of single inheritance, where A is the base class, or you can say the superclass, and B is the derived or subclass. So single inheritance is the inheritance where a derived class is going to have only one base class or only one parent class. Another type of inheritance is multi-level inheritance, where we can inherit a class from another class, and that inherited class can act as a base class for another type. That means this is our base class, this B is derived class of this A, but this B can act as a base class or parent class for this C. So you can create this inheritance hierarchy up to any level. So this type is called as multi-level inheritance. The next type is called as hierarchical inheritance, where one class can be inherited by several classes. Now these classes can be again further inherited by different classes. So this is different types of inheritance that are supported in Java. Remember, Java do not support multiple inheritance. Multiple inheritance is where a derived class can have more than one parent class. So Java do not allow us to create a derived class that inherits from two base classes. Remember this rule. Child class is actually a specialized version of parent class. Now imagine this inheritance hierarchy. I have this class shape that encapsulates common properties related to all the shape. Now, if I create two different classes, rectangle and triangle, and these classes inherits from this shape class, so we can say this triangle is a shape and this triangle is a specialized version of this shape. Okay, so each derived class takes common properties from its base class and it adds its own unique attribute to it. We have just seen in the example that this child class, permanent employee, acquires all common properties from employee class and it adds its own unique attribute to that particular type. Now let's have a look at constructors in the inheritance class hierarchy. Suppose I have this class A, which is my superclass or parent class, and I have this B class that inherits from this A. So if I create an instance of this class B, so this parent class also gets instantiated for this object, because we have just learned that this type is the specialized version of this type. And again, parent class constructor executes prior to child class constructor. Let's have a practical look at this. Let me remove all these code. Suppose I have this class and let's name it my base class or my parent class, and let's add a constructor within this class. And if this constructor executes, let's print a message: parent class constructor executed or parent class initialized. Now let's create an inherited class or a subclass of this particular type. So let's name it my child class that extends my parent class, and let's add a constructor that is my child class. And if this constructor gets executed, let's print the message child class instantiated. Now if I create an instance of this my child class, let's name it x equals new my child class. We have just learned that a child class is a specialized version of its parent class. So this class can do all the things which this class can. So if I create an instance of this class B, the instance of this class also created for this B instance. So if I create instance, even if I create instance of this class B, constructor of class A executes prior to the constructor of this type B. So if I create an instance of my child class, the first constructor that executes is this one. After instantiating the parent class, this constructor gets called. So let's compile this and run this, and now look at the output. I have created an instance of child class, but look at the output. It's saying parent class instantiated and then child class instantiated. So this proves that whenever you create an instance of child class, an instance of its respective parent classes also get created, and the constructor of parent class executes prior to the constructor of child class. Now we have learned these two rules. Now let's look at this rule. If parent class constructor takes any parameter, it must be passed from child class constructor. In other words, we can also say if a parent class has default constructor, that means non-argument constructor, or this class do not have any constructor, in both the cases there is no restriction on this class to have a constructor. This class may or may not have any constructor. But suppose this parent class have only parameterized constructor. There is no argumentless constructor or default constructor in this class. Suppose I am going to print this message also. So the situation is our parent class has only parameterized constructor. So in this case, your child class must have a constructor. If I remove this constructor and try to compile this program, now look at the error. Constructor my parent class in class my parent class cannot be applied to given types, that is my child class. Why is that? Because if parent class constructor takes any parameter, it must be supplied from child class constructor. So we need to write a constructor over here, and from within this constructor I need to supply the data that is required by this constructor. So how to supply that data? So Java has this super keyword. So super refers to the parent class instance. That means I have created instance of this child type. So this refers to instance of that particular class type. Similarly, super refers to the instance of its parent class. So it is used to invoke parent class constructor from child class constructor. Similarly, it is also used to invoke or access parent class members from child class. So let's have a look at this first particular use of super keyword, that is to invoke parent class constructor from child class constructor. So let's say super, and what arguments this constructor is expecting? It is expecting a string type of parameter. So let's print a message hello from child class. Okay, now if I create an instance of this my child class, program will arrive within this constructor. It will call the parent class constructor first, and this hello from child class will be passed as a parameter into this message. Then this system.out.println statement will execute. It will print parent class instantiated, and the message will be displayed as hello from child class. After completion of this constructor, The remaining code from this constructor will execute, that will print child class instantiated, and then program will return in the main program. So compile this and run this. Now look at this. Parent class instantiated and message is hello from child class. So this is how we can invoke parent class constructor from child class constructor using this super keyword. And remember this rule: if parent class constructor expects any kind of parameter, all these parameters must be supplied from child class constructor using this super keyword. Now if I remove this super keyword from this line and if I paste it over here, and now let's try to compile this. Now look at the rule, look at the error. Constructor my parent class in my parent class cannot be applied to given types, that is child. So remember this rule: super must be the first statement in the child class constructor. So I need to move this statement from this line to this line, and now if I compile this, it will be happily compiled and executed. Now this super keyword is also used to invoke or access a parent class member from child class if it is hidden by the same name of a member within child class. Now let's see what I mean by that. Suppose I have this my parent class and I have this my child class, and let's say I have this I variable that contains 10, or I have this a variable that contains 10. I also have a variable with the name a that contains 20. Now look at this. This member is hiding this member due to the same identifier. Now if I add this print method within this child class, and suppose I am going to print this a from this child class. So let's create an instance and let's invoke this print method from this child class instance. So this print method is trying to access a, and definitely it will access the a of that class itself, so it will print 20. But what if I want to print this a? So I can make use of this super keyword. We have just learned that super refers to the parent class instance. So if I say super.a, so super.a means the instance of this class contains an instance variable that is a. So that variable a, which belongs to the parent class instance of this class. So I can access member of parent class using this super keyword. So now compile this and run this. Now look at the output. It is displaying 10. That means when I say super.a, it is actually printing this a. So there are two different usage of super keyword. First, you can invoke parent class constructor from child class constructor using super keyword. There are few rules. That means super should be the first statement in child class constructor. The another use of super keyword is using this you can invoke or access parent class members from child class. That means I am accessing this variable using super keyword. Thank you for watching. For more details, visit our official site, that's risingtechnologies.in. You can also subscribe to my YouTube channel.